Hello, everyone, and welcome to our module on Exploratory Data Analysis, or EDA, as it is commonly known in the data science community. I am Ibrahim Malik, and today we are going to dive into one of the most critical phases of our machine learning project. We will explore four key components of EDA: data cleaning and processing, feature engineering, data visualization techniques, statistical analysis. These steps are essential for detecting patterns, identifying anomalies, and ensuring your data is in optimal shape before feeding it into any machine learning algorithm. Remember, a model is only as good as the data it is trained on. Okay, even the most sophisticated algorithm can compensate for poor quality data. As the saying goes in our field, garbage in, garbage out. All right, data cleaning and pre-processing is where our EDA journey begins. I can't overstate its importance, okay? Uh, and decades of experience in technology, I've seen countless projects fail because teams rushed past proper data cleaning. So let's talk about some common data issues you will encounter. First, missing values. These are inevitable in real world data sets. You have several options for handling them. You can impute them using statistical measures like mean, median, or mode. For time series data, you might use forward or backward fill techniques. In some cases, if the percentage of missing values is significant, you might decide to drop those features or samples altogether, right? Next, we have duplicate records. These are severely bias your these can severely bias your analysis and modeling. Always scan for and remove duplicates as part of your pre-processing pipeline, right? Outliers are another critical consideration. While sometimes they represent errors, they can also contain valuable information, right? So you'll need to make case by case decisions. Do you remove them, cap them, or perhaps is them? Finally, normalization and scaling, right? Many learning algorithms perform better when features are on similar scales, right? Common techniques include minimum maximum scaling, which transforms features to a range between 0 and 1, right? Or zero score is which gives feature a mean of 0 and a standard deviation of 1. Or log transformation for highly skewed distributions, right? In AWS environments, services like Glue Data Brew can automate many of these pre-processing steps, saving you time while ensuring consistency. Remember, the cleaner your data is at this stage, the more reliable your subsequent analysis and modeling will be. So never underestimate the power of clean data. Now that we have clean data, let's talk about feature engineering, the process of transforming raw data into meaningful features that our models can understand. Okay, so feature engineering is where domain expertise meets technical skills. It's both an art and a science, and often makes the difference between average and exceptional model performance. So, for categorical variables, we have several encoding options. One hot encoding creates binary columns for each category. Label encoding assigns a unique integer to every category. And target encoding replaces categories with the mean of the target variable for that category. Okay. And for continuous variables, sometimes it makes sense to bin them into discrete categories. For example, age might be more meaningful when grouped into range like 18 to 25, 26 to 35, and so on, right? Feature is where creativity comes in. By combining existing features, you can create new ones that better capture underlying patterns. For instance, in an e-commerce dataset, calculating average purchase value from total purchases and number of purchases might yield valuable insights. When dealing with high-dimensional data, techniques like PCA, principal component analysis, can reduce dimensionality while preserving essential information, and that makes your model more efficient. Okay. Remember, the goal of feature engineering is to enhance your model's ability to learn platforms from the data. The better your features, the better your results. All right, let's talk about data visualization now. Okay, with clean data and engineered features in hand, visualization becomes our next powerful tool. Okay, as the saying goes, a picture is worth 1,000 data points, right? So, effective visualization reveals patterns, relationships, and anomalies that might remain hidden in tables of numbers. All right, so let's explore some essential visualization techniques. Uh, Scatter plots are excellent for examining relationships between two continuous variables. They can immediately reveal correlations, clusters, or outliers, right? Uh, Adding a trend line can further highlight the direction and its strength of relationships. Box plots give you a statistical summary of your data's distribution. It clearly highlights median, quartiles, and outliers. They're particularly useful when comparing distributions across different categories. And then histograms and density plots show the distribution of a single variable, helping you identify if your data is normally distributed, is skewed, or multimodal. This information is crucial for selecting appropriate statistical test and modeling approaches. So, correlation matrices provide a big picture view of how all your variables relate to each other, helping identify potential multicollinearity issues before modeling. Okay, that's a really difficult word for me to pronounce. Multicollinearity. I'm not a native English speaker. English is my second language, so excuse me for that. All right, in the AWS ecosystem, QuickSight offers powerful visualization capabilities with minimal step for Python users. Libraries like Matplotlib, Seaborn, Plotty. Plotting provides extensive visualization options, right? While tools like Pandas profiling can generate comprehensive EDA reports with just a few lines of code. And remember that visualization isn't just about making pretty charts, okay? It's about gaining insights that drive decision making in your data science workflow.